Hi everyone, today we'll be working on question 876 on LeetCode today called middle of the linked list. We just want to find the middle of the linked list, pretty straightforward. So the naive approach to this question that I won't be implementing but I can discuss is that we'll traverse the entire list, maybe divide by 2, and then go back to the head and just move 2 up, and that will give us the middle of the list. But that's a little inefficient because you have to go to the end, back to the front, and iterate again. So there is actually a way to do this with a one pass. So the way to do it is with an algorithm called Floyd, Hare, and Tortoise algorithm. The idea behind this is we start with a slow and fast pointer, where slow moves 1 at a time, and fast moves twice as fast. And yeah, so in this example, for the middle of the linked list, slow will be the middle of the linked list once fast is done. So let's try it. Let's say let slow equals head, let fast equals head. So start both of them at the beginning. I can say while fast and fast dot next. Slow moves 1 up, while fast moves 2 up. Notice 2 things. I don't have to check for slow inside my while loop because slow will always be before my fast pointer. Also, I do have to check fast.next because we are checking the next after fast.next. So we need to make sure that this is not null as well. At the end, we return slow. So let's first see if this works. Yep, works. And works just fine. Cool. So now let's draw it out with paint with our 2 examples. So we'll try 1, 2, 3, 4, 5 and 1, 2, 3, 4, 5, 6. So let's do 1, 2, 3, 4, 5 first. Initially, my head and fast are both at the front. In my next iteration, my head will move to 2. Oops. Yeah, and my fast move to 3. And in my next iteration, my head will move to 3 and my fast will jump to 5. We will not do another iteration because there is no fast.next after 5. So we just return the head, which so happens to be at the middle of the list. So another way to interpret this is since fast is always going twice as fast, if fast represents the entire length of the linked list, head just represents, sorry, the other pointer, or the slow pointer, will represent just half of that, which is just half of the list. So let's just do it with one more. So I'll just make a new paint. So in the case of an even list, so something like 1, 2, 3, 4, 5, 6. Oh, I just realized this is a pencil. Our slow and fast will start here. Slow and fast. Then slow will be here, while fast will be here. Then my next iteration, slow will be here, while fast will be here. And since we can do technically one more iteration, slow will be here, while fast ends up becoming null. So we return 4. And we can see in the question that if there are 2 middle nodes, we return the second middle node, which is indeed 4. So this works for this case too. So that just, oh yeah, so sorry, let's just talk about the runtime real quick too. We're doing a one pass, which is O of n. So n is number of nodes. Cool, and that just about wraps up this question. good introduction to this algorithm. This algorithm is also very useful in finding cycles in linked lists or graphs. And we'll be seeing that a lot more when we go through other questions that use this algorithm. But for now, I'll end it here. I'll put a link to the question as well as my GitHub down below, and I'll see you guys next time.